All right, let's discuss the answers to the questions in the first slide, questions 1 to 6. Yeah, Gayatri, the first one.
Ma'am, n is equal to 8, ma'am.
No, read out your step. Okay, now tell me this. So this is the equation given. Root of 3 to the power n is equal to 81. Now, how do you get rid of the square root? How do you write that in the exponential form?
Ma'am, first it is square root of 3 to the power n is equal to 81 into 81, ma'am.
Okay, I'm sorry. Since your audio is not clear, I'm not able to get you. All right, so this square root is to the power of what, children?
Power of 1.
Raised to the power? 1 by 2. 1 by 2. All right. So square root, this is the radical form. No, disable your mic. Somebody's mic is enabled. Please disable it. Yeah. So this is the radical form. The exponential form will be to the power 1 by 2. If it's cube root, this is the radical form. The exponential form will be raised to the power 1 by 3 and so on. Fourth root raised to the power 1 by 4. Fifth root raised to the power 1 by 5. The square root, there's a 2 here. We don't write the 2 there. When we say square root, there's actually a 2 here. But see, like when we say 5, it is a positive 5. In the same way, when we write the symbol, it's understood there's a 2 there. It's a square root. So we don't write the 2. If we don't write 2, it's square root. If it's cube root, you have to show the 3 there. Okay. So get rid of the radical, the square root symbol. Get rid of the radical, the square root symbol. Okay, so remove that. In the next step, it will be 3 to the power n, the whole power 1 by 2. If it was cube root, then it will be to the power 1 by 3 is equal to, right, 81 in base 3, 3 to the power 4. 3 to the power 4. How? Because 81, 327 times, 3 9s are, 3 3s are, 3 1s are. So 81 is equal to 3 to the power 4. All right. So now, when the base is raised to many powers, so you'll have to multiply the powers. See, like if you have 3 to the power 2, the whole power 3, the whole power, say 1 by 2, and the whole power, whatever, like say -1. So the base is 3. The base 3 is raised to multiple powers, many powers, multiple powers. You just have to multiply the powers. 2 into 3 into 1 by 2 into -1. Multiply all the powers. You can see the base 3. The base 3 is raised to many powers, multiple powers. Multiply all the powers. 2 into 3 into 1 by 2 into -1. So whatever, this was just an example. All right, like this. So here, 3 to the power n into 1 by 2. Multiply the powers is equal to 3 to the power 4. 3 to the power n by 2 is equal to 3 to the power 4. So bases are same on both the sides. Equating the powers, we get n by 2 is equal to 4. Bases are same on both the sides. 3, 3 on either sides. So equating the powers, n by 2 is equal to 4. Don't cancel the 3, but it's like cancelling the bases on both the sides. Don't cancel, but it's like cancelling the bases, the equal bases on both the sides. So n by 2 is equal to 4. N by 2 is equal to 4. N is equal to 4 into 2, 8. Cross multiply 2 into 4, n is equal to 8. Okay, so this is one way. You can also do it like this. Okay, so square root of 3 to the power n is equal to 81. Squaring on both the sides. squaring on both sides. Squaring on both sides, we get the whole square is equal to 81 square. Squaring on both the sides. Alright, so now you know the square root and the square, they get cancelled. The square root and the square, they get cancelled, but don't show that. Alright, so when you have a square root, when the square root is squared, so it's like the square root and the square, they get cancelled. So we have 3 to the power n. 3 to the power n. See, supposing you have cube root of 3 to the power n, the whole cubed. So the cube root and cube, they're opposite operations, right? Cube root and the cube of. So like plus minus, opposite operations. Plus minus, multiplication, division. So like that cube root and raised to the power 3. So they are opposite actions. So they get cancelled. So if it's, so supposing you have 4th root of 3 to the power n, the whole raised to the power 4. So the 4th root and the 4. 4th root and the power 4 raised to the power 4. They're opposite actions. So you can just cancel them out. So here, when you square on both the sides, so it's like you're canceling the square root and the square, but don't show that, right? So next step, you have 3 to the power n is equal to 81, you know, is 3 to the power 4, and the power 2, which is already there. See, on this side, see, the first step is squaring on both the sides. So then raise both the sides to the power 2. And then I told you that the square root of the square gets cancelled. So we have 3 to the power n is equal to, don't find the value of 81 into 81. Since on the left hand side, you have the base 3, on the right hand side, write 81 and base 3. So 3 to the power 4 is 81. But there's already a power 2. So multiply the powers, 4 into 2. So 3 to the power n is equal to 3 to the power 8. Bases are same on both the sides. So the value of n is 8. Yeah, so as I, complete every answer, please take a screenshot. Or if you're writing along with me, if you're listening and writing along with me, that's also fine. Yeah, next one, the second one. We have 3 to the power x plus y is equal to 81.
Ma'am, can you please go to the previous slide for a minute, ma'am?
Yeah.
Thank you, ma'am.
Yeah. Gotcha. So in question number 2, we are given 2 equations. 3 to the power x plus y is equal to 81 and 81 to the power x minus y is equal to 3. All right. So from this we have, from the first one, we have 3 to the power x plus y is equal to 3 to the power 4. So bases are same on both the sides. Equating the powers, we have an equation x plus y is equal to 4. So this is one equation. The second one, 81 to the power x minus y is equal to 3. So 81 is nothing but 3 to the power 4 into x minus y is equal to 3. So 3 means 3 to the power 1. 3. There's no power, right? So the power is 1. It's not 0, it's 1. So again, bases are same on both the sides. Equating the powers, we have 4 into x minus y is equal to 1. 4 into x minus y is equal to 1. So x minus y is equal to 1 by 4. X minus y is equal to 1 by 4. Equation 2. X minus y, 4. When you transpose 4, On the other side, it will be 1 by 4. So that's the second equation. Now write the two equations one below the other. So solving equation 1 and equation 2. Okay, we get, so x plus y is equal to 4. X minus y is equal to 1 by 4. All right. So write the equations one below the other. Now, when you have two equations, you can add the two equations, you can subtract the two equations, you can multiply the equations, you can divide one by the other. You can perform any one of the four mathematical operations with the two equations. You can add the two equations, you can subtract, multiply, or divide. Now here, when you write the equations one below the other, you see that plus y minus y gets cancelled. So we'll add the two equations. Adding means, see, if you're subtracting, you will change the signs here. If you're subtracting the two equations, you will change the signs of every term in the second equation, the bottom equation, right? So if you don't change the signs, you're adding. If you change the signs, you're subtracting. For the terms in the second equation, if you change the signs, this bottom equation, if you change the signs, if you write the opposite signs, you're subtracting. If you don't make any changes, you proceed with the same sign, that means you're adding. So that way plus y minus y gets cancelled. X and x is 2x is equal to 4 plus 1 by 4. So 2x is equal to, on taking the LCM, you get 16 plus 1, right? 16 plus 1. So 2x is equal to 17 by 4. X is equal to x is equal to 17 by 4 into 2. X is equal to 17 by 8. Now you'll have to substitute this value of x in one of the two equations and find the value of y.
Mom,
Yeah,
mom, is the value of y is 15 by 8?
15 by 8, is it?
Yes, mom.
Okay. So 15 by 8 and 17 by 8, 15, 32 by 8. Yeah, correct. Correct. Gayatri, yes, good Gayatri. That's right.
Thank you.
So children, to work this, we use the rule when bases are same on both the sides, we can equate the powers. In the left-hand side and the right-hand side, when the base is the same, then you can equate the powers. That's how we get equation 1 and equation 2. Write the equations one below the other. We are adding the two equations. Equation 1 plus equation 2 is what we're doing. So when you do that, plus y minus y is 0. Plus y minus y is 0. So you can cancel them. X plus x, 2x is equal to 4 plus 1 by 4. So you get 2x is 17 by 4. X is equal to 17 by 4. 2 comes to the other side, to the denominator. So into 2. 17 by 8. Now substitute x is equal to 17 by 8 in equation 1. Okay, so what do you get? X plus y is equal to 4. X plus y is equal to 4. 17 by 8 plus y is equal to 4. Y is equal to 4 minus 17 by 8. Y is equal to 8 is a common denominator, so you get 32 minus 17. Y is equal to 15 by 8. So these are the values of x and y. That's the question, to find the values of x and y. Yeah, Aishwarya, tell me the answer for the third one. Read out your steps. Shreya.
Yes, ma'am.
Yeah.
I'm not sure if I've done it properly, but this.
Okay, then we'll do it together. Fine, fine. Then we'll do it together. Now tell me,
Okay.
what is, how do you write 7 to the power minus 1 in a different way?
You can write it as 1 by 7.
1 by 7, correct. 1 by 7,
Reciprocate it.
correct. Minus, what is the rule?
1 by 8.
Yeah, the rule is,
If there's a negative power, you have to reciprocal the base.
yeah, reciprocal of the base and write the negative of the power.
Yeah.
The negative of the power will be plus 1. So you
Plus
don't have
one.
to write that. Yeah,
Yeah.
correct.
So the whole and yeah.
Yeah. Next step.
Now I've written 7 minus 8 to the power 1. Like there's a minus 1 up over there, that's why.
Okay.
And then I've done the same with the other one.
No, that's wrong.
Yeah,
No. Okay, you can disable your mic because I think there's some noise from your background. Yeah, so here you'll have to take the LCM, children. 7 8 are 56 is the LCM. So 8 minus 7, the whole power minus 1 minus 12 is the LCM. So 4 minus 3, the whole power minus 1. So we have 1 by 56, the whole power minus 1 minus 1 by 12, the whole power minus 1. So again, the power is negative. So if you want to make the power positive, or if you want to write the terms in a different way, you want to write 1 by 56 to the power minus 1 in a different way with a positive power. Then the rule is take the reciprocal of the base, 1 by 56, the reciprocal of the base, 56 by 1, which is 56. Reciprocal of the base, negative of the power, minus 1 is written as plus 1. Reciprocal of the base, 1 by 56 is 56. Reciprocal of 1 by 56 is 56. The negative of minus 1 is plus 1. So 1 by 56 to the power minus 1 can also be written as 56 minus, yeah.
Mom, in the question that is given 7 minus 8, ma'am, but why if you written as 8 minus 7, ma'am?
When you take the LCM, 7 into 8 is 56. No? So into 8 here.
Oh, okay.
Then 8 sevens are, so into 7 here. Then here
Okay.
3 4s are 12, so into 4. And then 4 3s are, so into 3 here.
Okay.
Yeah. And 1 by 12 to the power minus 1. So again, reciprocal of the base and negative of the power. 44. Yeah, please ask me anywhere if I need to explain more clearly. Please ask me.
No, ma'am.
Okay. So when the power is negative, so supposing we have minus 8 by 5 to the power minus 2. And you want to write this with a positive power. A positive power. The power here is negative. You want to write the same thing. You want to write the equivalent of this with a positive power. So the rule is take the reciprocal of the base. Reciprocal of the base minus 8 by 5 minus 5 by 8. And now write the negative of the power. Minus 2 is plus 2. When you do this, you're writing the equivalent of this one. These two are equal. But if you do only one of the two actions, here the two actions are taking the reciprocal of the base and writing the negative of the power. So these two actions, if you perform both these actions, you are writing the equivalent of the given expression. If you perform only one of these two actions, then you're writing the reciprocal of the given expression. So here again, minus 8 by 5 to the power minus 2. Supposing you write the reciprocal of the base, which is minus 5 by 8, and you write the power as it is. Now, these two are not equal. They are reciprocals of one another. If you do only one of the two actions, the two actions here are writing the or taking the reciprocal of the base and writing the negative of the power. Power, you should change the sign. Plus becomes minus, minus becomes plus. Base, you should take the reciprocal. If you do both these actions, you will get the equivalent of the given expression. If you perform only one of these two actions, the two expressions will be the reciprocals of one another. So here, if you write the reciprocal of the base, minus 5 by 8, but you write the power as it is, minus 2. So these two are not equal. They are reciprocals of one another. Or say you write the base as it is, minus 8 by 5. But you write minus 2 as plus 2. You write the negative of the power. Base you've written as it is. But power, you change the sign. Minus 2 becomes plus 2. So again, these two are reciprocals of one another. They're not equal. So that's the rule we've used here. So 7 to the power minus 1 is equal to, what is 7? 7 means 7 by 1. 7 means 7 by 1. 7 to the power minus 1 is nothing but 7 by 1 to the power minus 1. Reciprocal of the base is 7 by 1. Reciprocal, 1 by 7. Negative of the power, minus 1 becomes plus 1. So this is nothing but 1 by 7. This one is nothing but 1 by 7. That's what we've done everywhere. 8 to the power minus 1. 8 means 8 by 1. So its reciprocal is 1 by 8. The power is minus 1. So it's now plus 1 or simply 1, but you don't have to show. So 8 to the power minus 1 is nothing but 1 by 8. The usual form of Lakshana, what's the usual form?
Ma'am, it's 0.203.
Correct. So 2.03 into 10 to the power minus 1 means 1 by 10. 1 by 10. 10 to the power minus 1 means 1 by 10. So there's nothing but 2.03 by 10, which is 0.203. When you divide, the value of the numerator will become smaller. When you divide by 10, the value of the numerator will become still smaller. You're dividing. If you're multiplying, it will increase. Multiplying again by a fraction, it will not. See, like if you multiply 4 by half, every time you multiply, it will not keep the increasing in values. If you multiply 4 by half, then it's 2. Because when you're multiplying by a fraction, it's like dividing. See, 4 divided by 2 is what is 4 into 1 by 2. That's why I've shown a few steps here. So 10 to the power minus 1 is nothing but 1 by 10. So this is nothing but 2.03 divided by 10. You're dividing the numerator by 10. So it will reduce in value. And the denominator has 1 0. 10 has 1 0 in it. So the decimal point will be shifted to the left because you'll have to reduce the value to the left by 1 place because only 1 0. When you're dividing by 10, the value in the numerator will reduce further. So you should shift the decimal point to the left. And 10 has 1 0 on it. So shift the decimal point to the left by 1 place. And that's how we get 0.203. If supposing it was 2.03 divided by 1000, supposing divided by 1000, so 3 zeros. So you'll have to shift the decimal point by 3 places. Now 3 places, okay, left or right, should make it smaller because you're dividing by 1000. The numerator is divided by 1000. So the value of the numerator will reduce. Reduce means you should shift the decimal places to the, reduce means you should shift the decimal place or the decimal point to the left. 3 zeros, right? So you should move by 3 places to the left. So that will be 0.00203 because it's here, no? 1, 2, 3. Yeah. So we know anything raised to the power 0 is 1. 1 by 64 to the power 0. Anything raised to the power 0 is 1. A to the power 0 is 1. All right, so 1 by 64 to the power 0 is 1 plus 64 can be written as, you can write it in base 2. Write it in a base so that the power, we have in the power, we have 1 by 2. The 2 gets cancelled out. So you can write 64 as 8 square. See, supposing the power was 1 by 3. Supposing the power was 1 by 3. Then you can write 64 as 4 cubed. If supposing the power was 1 by 3, or minus 1 by 3, you can write 64 as 4 cubed. 3 and 3 cancels. You can also write 64 as 2 to the power 6. Now here we choose to write it as 8 squared because we have the power minus 1 by 2. Okay, so 64 is 8 squared and there's a power already there. So multiply the powers like this. Plus 32 is 2 to the power 5. 32 is 2 to the power 5. See children, you know this like this. 16 times 2 8s are 2 4s are 2 2s are 2 1s are. So 2 into 2 into 2 into 2 into 2. 2 to the power 5. 32 is 2 to the power 5. There's already this power 4 by 5. So multiply. Minus 32 is 2 to the power 5. And the power minus 4 by 5. So 1 plus 2 gets cancelled. 8 to the power minus 1 plus 5 cancels. 2 to the power 4 minus 5. 2 to the power minus 4. 1 plus So what is 8 to the power minus 1? 8 to the power minus 1?
1 by 8.
1 by 8. 1 by 8 plus, what's the value of 2 to the power 4?
16.
16. The value of 2 to the power 4, 16 minus, and how do you write 2 to the power minus 4 with a positive exponent?
1 by 2 raised to the power 4.
Very good. Very good. Now 16 plus 1 is 17. 16 plus 1, 17. So 1 by 8 plus 17 minus 1 by 16. Common denominator 16. So into 2 into 2. So you get 2. And here it is by 1. So into 16 into 16. So what is 17 into 16? 17 into 16. 272 plus 272 minus into 1 into 1. So minus 1. So 272 plus 2, 274 minus 1, 273 by 60. You can write this as a mixed fraction or you can leave it like this. It's fine. So here in the power, we have some fractions. 1 by 2 minus 1 by 2, 4 by 5 minus 4 by 5. So here what you have to do is you need to write the base in the exponential form using a suitable base. Now like 32, you have no choice. You have to write it as 2 to the power 5. 32 is 2 to the power 5. Now a number like 64, 64 can be written as 2 to the power 6. It can be written as 4 to the power 3. All right, it can be written as 8 squared. See, you can write it anyways, you will get it. 1 minute, let me just show you that in the next one. See here, 64 to the power minus 1 by 2 children. Not that you should write it only as 8 squared. Now, supposing you write it as 4 cubed. Okay, so 4 cubed to the power minus 1 by 2. And you're not happy with what you're written because nothing, the powers are not getting cancelled, right? See, you write 64 as 4 cubed. But you're not happy because you cannot simplify this. So what you should do is 4 should be further written as 2 squared. Write 4 as 2 squared. 4 can be written as 2 squared. Now this power 3, we know that how many of powers we have, we simply have to multiply all the powers. So 4 is 2 square, but there's the power 3. So into 3, there's another power minus 1 by 2 into minus 1 by 2. 2 and 2 cancels. Now you're happy. 2, 2 cancels. So 2 to the power minus 3. So that's what we got here also. See here, 2 to the, okay. 2 to the power minus 3, which is 1 by 2 cube, which is 1 by 8. See, that's what we have here, 1 by 8. But you have to do, it'll involve a few more steps. So if you see a 2 here, if you see the power 1 by 2, if you write 64 as 8 squared, straight away the 2 and 2 will get cancelled. That's all. You'll just save on time and those few steps. Otherwise, you can write it with any base. The answer will not be different, or it's not that you will not get the right answer. You will get the same correct answer. You might need to write a few more steps. Yeah, anyone wants to share the answer for the sixth one? Children, use the emoji. Raise your hand. Yarni, Shriya, Lakshana, Shivam. Aishwarya and Gayatri. Okay, Gayatri is there. All right. Thank you, children. Yes. So we'll first find the value of x by y. All right. We'll find x by y. And then we can find x by y to the power -2. So now, again, 1 by 3 to the power -4 can be written as? What's the other way of writing 1 by 3 to the power 4? -4, sorry.
3 to the power 4.
3 to the power 4 divided by. Now, 1 minute, let me not do this. Yeah.
No, we have to change. I'm asking that we have to keep it as -3 by 2 or 3 by -2.
You're asking about the base -2 by 3, is it? If we should.
Yes,
no, I don't. The minus, where to put the minus sign, is it?
Yes, ma'am.
That's okay. You can always put it in the numerator.
Okay.
Yeah. Okay. So 1 by 3 to the power -4 is 3 to the power 4. Now, supposing we change the division to multiplication, children. If you change this division to multiplication, you must write the reciprocal of this one, right? Yes or no? See, when we have 3 by 4 divided by 2 by 1 second. Divided by, say, 9 by 20. So 3 by 4. Division becomes multiplication. And we write the reciprocal of 9 by 20 as 20 by 9. We perform the simplification. 3 1s are 3 3s are 4 1s are 4 5s are and 5 by 3. In the same way here, division becomes multiplication and you have to write the reciprocal of this one. So as we have understood, to write the reciprocal of an expression, you must do only one of the two actions. Either take the reciprocal of the base or the negative of the power. So we'll take the negative of the power because anyways, we don't want the power to be negative, right? We want it positive. So you choose the right option. If it's already positive, if the power is already positive, then you take the reciprocal of the base. Here the power is negative, so you want to make the power positive. So do that. Write -3 as +3, but write the base as it is. When you do only one of the two, when you do one of the two actions, you're writing the reciprocal. And now we have to write the reciprocal. Because when you change division to multiplication, you will have to write the reciprocal of the term that follows the division sign. Sorry. Yeah. So now this is nothing but 3 to the power 4 into -2 to the power 3 by 3 to the power 3. Or you can also write it like this, children. You can also write it like this. You can write it 3 times. You can write that 3 times. One of the I'm not writing it like this. I'm saying like you can write it 3 times like this. -2 by 3 to the power 3 means -2 by 3 into -2 by 3 into -2 by 3. So you can cancel the 3's. 3 3's here and there is one. There are 3 3's here also. 1 3 will remain. You can do this. I'm not doing that. You can do that, but let's try to maintain the exponential form as far as possible. So 3 to the power 4 into -2 to the power 3 by 3 cubed. So x by y is equal to 3 to the power 4 by 3 to the power 3 into what is minus 2 into minus 2 into minus 2 minus 8. X by y is equal to, so here when you use the law of exponents, 3 to the power 4 minus 3 into minus 8. This, what's here, in the denominator, 3 to the power 3, you can take it to the other one also, 3 power 4 divided by 3 power 3 into the value of minus 2 the whole cube is minus 8. So now when base are same and its division, we subtract the power. So 4 minus 3. So we have x by y is equal to 3 to the power 1, which is 3 into minus 8. So x by y is equal to minus 24. So now we need to find x by y to the power minus 2. Therefore, x by y to the power minus 2 will be equal to this one to the power minus 2. X by y is minus 24. X by y is minus 24. So x by y to the power minus 2 will be minus 24 to the power minus 2, which is nothing but minus 1 by 24. Reciprocal of minus 24 is minus 1 by 24. Reciprocal of minus 24 is minus 1 by 24. Reciprocal of the base, negative of the power. So that's nothing but okay. So that's nothing but minus 1 by 24 into minus 1 by 24. Minus into minus plus 1 by 576. Aishwarya and Lakshana, are you there? Both of you?
Yes, ma'am.
Aishwarya? Okay. Why you have some problem with your mic? Oh, you can't unmute. Okay. Okay, fine. See, if you're finding it easy, able to understand, good. If you're able to understand, but not comfortable, you understand? Yeah, it's not comfortable. You understand, but you're not finding it comfortable. Then you need to practice. So before the next class, work out the same questions. Recall, how we have understood. Practice the same. With practice, everything becomes easy. Everything can be conquered with practice. Where there's a will, there is a way. If you want to do it, if you want to make it easy, practice and it will become easy for you. It's not enough working, so that's what, as I said, you understand, but you're finding it difficult to remember. Then you have to practice to remember. Simply working it once in the session like now will not help you to retain. To retain, you have to practice, and please do that. Next one. Have you all finished this paper on exponents, children, or are you still working?
Still working, ma'am.
Which one?
The third one.
Third one. Yeah, one by one. Tell me, Lakshana, which one are you working?
Ma'am, I completed.
You completed exponents or even algebra?
Ma'am, even algebra.
You completed even algebra. Okay. What about Shreya?
Sorry, ma'am, I'm blabbering something. I'm just moving to algebra.
Okay. Yarni? Shivam?
I'm going to complete exponents.
Okay. Gayatri?
9th question, ma'am.
Okay. And Aishwarya? Okay. Aishwarya? Last question on exponents. Oh, you were so quick to type that. Okay. All right. So find the number. Find the number. You can use the place value chart. So 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0, decimal point. Correct? 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, and so on. This is how you write the place values in the exponential form. This is how you write the place value in the exponential form. Let me just write it again, once again. See, it's like thousands, hundreds, tens, ones, decimal point, tens, hundreds, thousands. All right. So this is thousands, hundreds. This is thousands, hundreds, tens. So this one is 1000, which is 10 cubed. 100, which is 10 squared. 10, 10 to the power 1. 1, 10 to the power 0. Anything to the power 0 is 1. So ones is 10 to the power 0. 10 is the tens place is 10 to the power 1. Hundreds 10 to the power 2. Thousands 10 to the power 3. Because 10 cubed is 1000. 10 square is 100. 10 to the power 1 is 10. And 10 to the power 0 is 1. Decimal point. 10 to the power minus 1. 1/10. 1 by 10. 10 to the power minus 1. 1 by 100. 10 to the power minus 2. 1 by 1000, 10 to the power minus 3. So this is the place value chart in the exponential form. Now just write the digits in the respective place values. So in the place 10 to the power 3, we have the digit 6. And then in the place 10 to the power minus 3, we have 6. And nothing in the middle. So 0, 0, 0, decimal point 0, 0. This is the number. The number is 6000.006. Find the number. The question is find the number. So you don't have to actually, write the place values and all that. You can just put your answer like this here. 6 into 10 to the power 3 plus 6 into 10 to the power minus 3. So just do it in your mind. In the place 10 to the power 3, you have 6, right? Then after 10 to the power 3 is 10 to the power 2. That's nothing. So put a 0. Then 10 to the power 1. There's nothing. Put a 0. After 10 to the power 1, it is 10 to the power 0. There is no digit there. So put a 0. Then decimal point. Then comes the place 10 to the power minus 1. There's nothing. 10 to the power minus 2. Nothing. 10 to the power minus 3, 6. That's all. You can just write it like this. 8 into 10 to the power minus 4. So here we don't have the whole number part at all. That is, we don't have any digits before the decimal point. It's only 8 into 10 to the power minus 4. So start with 0, 0 point, 10 to the power minus 1, nothing. 10 to the power minus 2, nothing. 10 to the power minus 3, nothing. 10 to the power minus 4, 8. It's only 8 into 10 to the power minus 4. So start with 0 point, 0 point, 10 to the power, in the place value 10 to the power minus 1. There's no digit, so put a 0. In the place 10 to the power minus 2, no digit, 0. 10 to the power minus 3, 0. And 10 to the power minus 4 is 8. So this is the number. Next one. Yeah, what's the answer you've got, Lakshana?
I got it as minus 6 by 11 to the whole power 4.
What by 11?
Minus 6 by 11.
6 by 11. Okay. Okay. So it's just prime factorization. It's not that we choose to divide by 11. 14,641 is divisible by 11. It will not be, it's not divisible by 2, 3, 5. You can check it's not divisible by 2, 3, 5. Not divisible by the primes before 11. It's divisible by 11 only. So 11 and again 11 and again 11 and again 11. 1296, you can see. Always start from the least prime, 2. If that's not possible, then 3, then 5, then 7. Don't pick prime numbers randomly. Always start with, meaning use it in the order. 2, and then 3, and then 5, and then 7, 11, 13, and so on. So I've just put the minus outside. We have found the prime factorization of 1296 and 14641. So 1296, you can see the numerator, and 14641 in the denominator. So 2 power 4 into 3 power 4 by 11 power 4. So all of them have the same power 4. So write them as whole power 4. 2 into 3 by 11, the whole power 4. 2 into 3 is 6, 6 by 11 to the power 4. Minus of 6 by 11 to the power 4. So again, using the prime factorization method, you will get minus 5 by 7, the whole power 3. 5 into 5 into 5 is 125. 7 into 7 into 7 is 343. 7, 7 is 49. 49 into 7 is 343. Okay, let me write that. Yeah, Lakshana, because you finished, what's the answer for this one? The final answer.
No, I got it as 125.
125. Okay, read out your steps.
Ma'am, since it's to the power 1.5, I wrote it as 0.04 to the whole power minus 15 by 10. And I wrote
3
0.0.
by 10. 15 by 10.
So since it is 0.04, I wrote it as 4 by 100 to the whole minus 15 by 10.
Okay.
Since the power is negative, I reciprocaled it. So I got 100 by 4 to the whole power 15 by 10. And next I wrote 100 by 4 in terms of the power 2. So I got 10 by 2 to the whole power 2 into 15 by 10. So upon cancelling the powers, I got 10 by 2 to the power 3, which is 1000 by 8, and that is 125.
Okay. Very good. So 0.04 is 4 by 100. And minus 1.5 is 15 by 10. Now we'll reduce this. 4 ones are 425 times. And here 5 threes are 5 twos are. So we have 1 by 25. The whole power minus 3 by 2. So the power is negative. We need to make it positive. So take the reciprocal of the base and write the negative of the power. So 3 by 2. Now 25 is 5 squared into 3 by 2. So 2 and 2 gets cancelled. So 5 to the power 3, which is 125. Zero 0.04 is 4 by 100. 1.5 is 15 by 10. That's the first step. Then simplify. 4 ones are 425 times is 100. And 15 by 10 reduces to 3 by 2. So we have 1 by 25, the whole power minus 3 by 2. Negative power, we need to make it positive. So take the reciprocal of the base. 1 by 25 becomes 25 by 1, which is 25. Minus 3 by 2 becomes plus 3 by 2. Next, 25 can be written as 5 squared. 25 is 5 squared, but there's already a power 3 by 2. So multiply the powers. 2 into 3 by 2. 2 cancels out. 2, 2. So 5 cubed, which is 125. So anything to the power 0 is 1 plus 1 by 4 into 4. 2 square is 4. 1 plus 1 by 4 into 4. So you'll get 4 plus 1. LCM. 4 plus 1. 5 by 4 into 4, which is equal to 5. 4 and 4 cancels. The standard form means writing it in the form k into 10 to the power n, where k is any value from 1 but less than 10. From 1 but less than 10. And n can be a positive or a negative integer. Okay, a positive or a negative number, which means n can be any integer. Writing a number in the form k into 10 to the power n, where k can be 1 or anything more than 1 but less than 10, and n is any integer. So you need to bring this number to a value which can be 1 or anything more than 1 but less than 10. And you should do that by shifting the decimal point. So 8649.005. Move it. 864 it is. 864. No. 86.4. No, it's more than 10. 8.6. Yes. Now this is between, it's less than 10. More than 1, but less than 10. The decimal point is here. Shift the decimal point in such a way that is shifted to the left or right, any direction you can shift. But the net result should be a number which is 1 or more than 1 but less than 10. To get a number in this range, shift the decimal point accordingly. So you have to move it to the left. Supposing you move it and leave it here, it is 864.9005. That's more than 10. Supposing you shift it here and leave it there, 86.49 and something. No, 86, it's more than 10. So you shift it like this. It's 8.649005. 8.649005. Yeah, 8.6 is between this range or is in this range. 1 or more than 1 but less than 10. So write this number as 8.649005. 1, 2, 3 places we have shifted the decimal point. 1, 2, 3. We have shifted the decimal point by 3 places. Now, by shifting the decimal point, we have reduced the value of the given number. The number was 8,649.005. And by shifting the decimal point, we have reduced its value. So raise 10 to a positive power. If you reduce, if the value is now less than the given number, you have reduced the value of the given number. So raise 10 to a positive power. If you have increased, if the given number, if the value which you have in the answer is more than the given number is small, but in the answer, by shifting the decimal point, you've increased its value. Then you should raise 10 to a negative power. If you've increased the value, raise 10 to a negative power. If you've reduced the value, raise 10 to a positive power. Opposite effect. If you've reduced, positive power. If you've increased, negative power. Opposite actions. So here the number in the question is 8,649, and you have brought it down to 8. You have reduced it. You have made it 8 point something. So raise 10 to a positive power. And the power will be the decimal point you've shifted by 3 places. 1, 2, 3. So it's a positive 3. Scientific form. Standard form, scientific form or scientific notation. So you can see the result is in the form k into 10 to the power n. K into 10 to the power n, where k is this value. It's in the range 1 to 10. It can be 1 also or anything more than 1, but less than 10. So it's in that range. Into 10 to the power n, where n is 3. N can be any integer. N is 3 here. So 1, 2, 3, 4, 5, 6, 7, 8. Then only it becomes 8.1. 1, 2, 3, 4, 5, 6, 7, 8. If you move the decimal point to the right by 8 places, then the number becomes 8.1. But you've increased the value. It was 0.000 something. You have increased its value to 8. So raised 10 to a negative power. Negative 8 because you've shifted the decimal point by 8 places. Are my answers correct, children? Have you got the same answer?
Yes, ma'am. Yeah, ma'am, I got the same answer.
Okay. So to find the total mass, you need to add the two expressions. Total mass is equal to mass of Earth plus mass of Moon. Mass of Earth is 5.97 into 10 to the power 24 plus Moon is 7.35 into 10 to the power 22. Yeah. So we need to write 24 as 22 plus 2. That's the first step. write 24 as 22 plus 2. That's the first step. Then 5.97 into 10 to the power 22 plus 2 can be written as 10 to the power 22 into 10 to the power 2. Because when bases are same, it's multiplication, we add the powers. When bases are same and it's multiplication, we add the powers. So if we have 10 to the power 22 plus 2, you can write it as 10 to the power 22 into 10 to the power 2. You can see your base is same and it's multiplication. So it's when it's like this, then you'll add the powers. So that's when you get 10 to the power 22 plus 2. So write that earlier step. Write the previous step. First write 24 as 22 plus 2. Then how will you get 22 plus 2? How will you have 10 to the power 22 plus 2? Then it should have been 10 to the power 22 into 10 to the power 2. Plus no change here. Sorry, children. Yeah. No change there. No change in the second one. Now 10 to the power 22 is common. Open a bracket. 5.97 into 10 squared. 5.97 into 10 squared. Plus 7.35. Because 10 to the power 22 is common. It's taken outside. So we just have to write the remaining 5.97 into 10 squared from the first part plus 7.35 from the second part. So 10 to the power 22. This is nothing but 5.97 into 100. 10 square is 100 plus 7.35. Sorry, children, I've been continuously yawning. I woke up very early this morning, so very sorry. 597 plus 7.35. 5.97 into 100. 5.97 into 100 is 597 plus 7.35. So 10 to the power 22 into, I think 604.35. 604.35. Now 10 to the power 22 into 6.0435 into 10 square. Write it in the scientific notation or the standard form. 604.35 is 6.0435 into 10 square. So one more step to go. So it is 6.0435 into 10 to the power 22 into 10 square. I'm just rearranging associative property. Just rearranging the terms. So 6.0435 into 10 to the power 22 plus 2. So 6.0435 into 10 to the power 24. This is the final answer. See, there's a procedure. It's not that, I'm just working as my mind says. No, there's a procedure. First, you need to take out, that 10 is raised to different powers, right? You need to take out something from their common. Now 10 is raised to the power 22 and 24. The smaller of these two is 22. So you can write 24 as 22 plus 2. See, you can also try like this, children. You can write 22 as 24 minus 2. That also is fine. That way also you will get the same answer. You can also write 22, the power 22 as 24 minus 2. I normally write the larger one in terms of the smaller one. So 22, 24. The larger one is 24. So write 24 as 22 plus 2. Because we have 22 here. So 22 plus 2. That's the first step. And 22 plus 2 meaning 10 to the power 22 into 10 to the power 2. Now, this is the first expression plus this is the second expression. We have 10 to the power 22 common. Bring it out. This one is common. So it comes out. Now write the remaining parts in the first and the second expression. So 5.97 into 10 squared plus 7.35. Don't write this 10 to the power 22. That's outside. It's taken out common. So now what you have to do is you have to simplify this bracket. You'll have to make this bracket one number. You have to simplify this bracket. You should make it one number. That's what we have done. So 5.97 into 10 square means into 100. And that means 597 plus 7.35, which is 604.35. Now, once you simplify the bracket to one number, you must write that number in the scientific form. I told you, I didn't do what I felt like or whatever my mind told me. There's a procedure. So after simplifying the bracket, that is after simplifying the bracket and getting one number, you need to write that number in the standard form. So it is 604.35. Standard form will be 6.04. Why? Because 1 to 10, 6.0435 into 10 squared. Now you can see 10 squared, 10 to the power 22. Bases are same. 10 to the power 2, 10 to the power 22. Bases are same and it's multiplication. So add the powers. 22 plus 2. So 10 to the power 24. The final answer should be in the standard form. And it is in the standard form. The final answer should be in the standard form. And it is. All right. So I hope in today's class we were, able to recall some important laws from this chapter exponents. So we'll see more like this from different chapters in the classes to come. Just a minute, children. I'll just stop the recording and I need to clarify a few things.